Exponents are the last new thing that we need to include in the order of operations. Where do they happen? Or does it matter? If we have, for instance, 3 times 5 squared, does it matter whether we multiply first or take the exponent first? Let's see. Well, 5 squared, that's going to be 5 times 5. 5 times 5, according to our multiplication table, will be 25. And 3 times 25, working that out off to the side. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. This is 75. On the other hand, 3 times 5, that's 15. So we'll have 15 squared, which is 15 times 15. Working this product out off to the side, 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. 1 times 5 is 5. 1 times 1 is 1. 5, 12, 2. This is 225. So we see that it does matter. So what do we choose? It turns out we choose this one. If exponents appear with other operations, we evaluate them before any multiplication or division, after only grouping symbols. So we can now state the full order of operations. Our first step is any operations inside grouping symbols, including parentheses. And if we have more than one layer of parentheses, we evaluate the innermost first. If we have more than one operation inside parentheses or another group, inside the groups we follow the usual order. Then, after we've finished up anything inside grouping symbols, we evaluate all exponents. After we've finished evaluating all exponents, we evaluate multiplication and division from left to right. And then finally, after all of the multiplication and division is done, we evaluate addition and subtraction from left to right. Now this order is arbitrary, it's just something we all agree on, but it's not really random, right? Addition and subtraction are really closely related, so it makes sense that they would be evaluated at the same time. Multiplication and division are really closely related, so it makes sense that they would be evaluated at the same time. More than that, multiplication is repeated addition. Exponentiation is repeated multiplication. So it makes sense that we would have kind of an escalating order from one to the next. And of course, grouping symbols being first, that's what they're for. They're telling us to violate the usual order and do this thing first. Now, there is a popular acronym you may have encountered to help you remember the order of operations. And it goes like this. P for parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. And some people pronounce this, they say PEMDAS. Some people have a mnemonic that goes with this. Please excuse my dear Aunt Sally. I don't like this acronym. Here's why. If you read this, you would think that multiplication comes before division, that addition comes before subtraction, and that parentheses are the only grouping symbol we have. None of those are true. I think we should get rid of this acronym. If you like acronyms and you like mnemonics, try this. G for grouping symbols E for exponents, M for multiplication and division, and A for addition and subtraction. If you like this mnemonic device, try goodness, excuse my aunts. Not only does this acronym help you remember that there are things that are not parentheses, that multiplication and division really go together, that addition and subtraction really go together, it also provides apologies for all of your parents' sisters, not just Sally. So now we can take any problem, no matter how long and drawn out and complicated, and just by following the order of operations systematically, evaluate even the messiest of expressions. Let's see an example. So here's an expression that I'm not going to try to read out, and it looks terribly complicated. But we know where to start. We're going to start by referring to all of the grouping symbols. What do we see for grouping symbols? We see, of course, these parentheses, and inside here we see this division bar. This division bar is inside another set of parentheses. This is our innermost grouping symbol. So we're going to take this and we're going to evaluate this expression first. We have off to the side 5 squared times 2 over 10. The divisor, there's nothing to evaluate, it's just 10. The dividend, I see an exponent and I see multiplication. Following the usual order, I know I should evaluate the exponent first. 5 times 5 is 25. So I'll have 25 times 2 over 10. 25 times 2, well, 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. So I'll have 50 over 10. 50 divided by 10, that's easy. We just knock off 1 0, and we get 5. So this whole expression evaluates to 5. And now I'm going to copy the rest of my original expression. What next? Well, do I still see any grouping symbols? Yes, I do. I see this grouping symbol and this grouping symbol. Neither one of those is inside the other, so I can pick whichever one I like better. I'm going to take this one to evaluate next. Again, because there are several operations in here, I'm going to take this off to the side. I'll have 5 squared divided by 5 minus 3. 5 squared I worked out earlier, that's 25. Doing the exponent first. And now division comes before subtraction, so I want 25 divided by 5. Well, I know that also from the multiplication table. 25 divided by 5 is 5. And 5 minus 3, that's 2. This expression evaluates to 2. And now I copy the rest of this. And notice I stopped writing these parentheses because I've already evaluated the expression inside. All right, do I still see any grouping symbols? I do, don't I? I see this one. 4 minus 2, that's easy. No need to take that off to the side. 4 minus 2 is just 2. And now, once again, I copy the rest of my expression. All right, now do I see any more grouping symbols? I do not see any more grouping symbols. So now it's on to exponents. Exponents don't really interact with one another, so I can work out whichever exponential expression I like better first. I like this one better for no particular reason. 2 to the third, that's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So 2 to the third, that's 8. And now once again, I'm copying the rest of my expression. I still see another exponent, 2 to the 0. What is 2 to the 0? 2 to the 0 is 1. Do I see any more exponents? I do not see any more exponents. Now it's time for multiplication and division from left to right. So, looking from left to right, this is the first place that I see multiplication or division. 2 times 2, that's 4. And now, again looking from left to right, this is the first place that I see multiplication or division. 8 divided by 1, that's 8. And now I only see one operation left. 4 plus 8 is 12. So this whole complicated expression is equal to 12. I want you to notice something about this, and that is that working this problem took up the better part of a page. These long, complicated order of operations problems are not difficult to work, but they do require patience, and they require a lot of space. With that in mind, I'm going to have you try one of these. Evaluate this expression. Pause the video and try this now. All right. So we begin with grouping symbols. I see this grouping symbol, a set of parentheses, this set of parentheses. Inside I see a fraction bar, and inside the fraction bar I see a couple of extra sets of parentheses. These two sets of parentheses appear to be my innermost grouping symbol. So I'm going to choose one of those to evaluate first. I think I'm going to choose this. 9 minus 6 is 3. And now I'm going to copy the rest of the problem. All right. My other innermost grouping symbol was this one. 12 divided by 4 is 3. And now I copy the rest of the problem. All right. My innermost remaining grouping symbol is this division bar. So I'm going to take this off to the side. I'll have 3 to the third over 3 times 3. In the dividend, 3 to the third, that's 3 times 3 times 3. 3 times 3 is 9. And 9 times 3 is 27. In the divisor, 3 times 3 is 9. And 27 divided by 9, that's 3. So this expression works out to 3. Now I notice that these parentheses only have a number inside them. Up here they were necessary to show that this exponent applied to the result of evaluating this group. But here they aren't necessary, so I can just stop writing them. The only grouping symbol that remains is this one. Inside I have 2 squared times 3. 2 squared, that's 2 times 2, that's 4. 4 times 3, that's 12. And now I have no grouping symbols remaining. What comes next? Correct, exponents. Now, exponents don't really interact with each other, so I can choose whichever order I like. I'm going to work out 3 squared first. 3 squared, that's 3 times 3, that's 9. Also see this exponent, 26 to the first power. Oh, but that's easy. 26 to the first power is just 26. All right, now no exponents remain. What comes next? Multiplication and division from left to right. So, scanning left to right, this is my first example of multiplication or division. 9 times 8, I know, is 72. And now, scanning again from left to right, I see this instance of division. 72 divided by 12, I'm going to work out off to the side. 12 doesn't go into 7, it does go into 72. After a few guesses, I find 12 times 6, 6 times 2 is 12, 6 times 1 is 6, plus 1 is 7. 12 goes into 72 exactly 6 times. And now, no instances of multiplication or division remain. Now it's time for what? Addition and subtraction, again from left to right. So here is an instance of addition. 25 plus 6. 5 plus 6 is 11. 1 plus 2 is 3. This is 31. And then the only remaining operation is this subtraction. 31 minus 26. 1 minus 6, I can't do it. I have to borrow. 3 becomes a 2. 1 becomes an 11. 11 minus 6 is 5. 2 minus 2 is 0. And left is 5. Our whole complicated expression evaluates to 5. Again, not difficult, just time-consuming. It requires that we work carefully.